Good morning, dear students. As I have already told you in the previous class that we would be starting with our types of bonding today, and we are here with ionic bond to discuss about ionic bond. Okay, the ionic bond is also called with another name electrovalent bond. Okay. The other term used for ionic bond is electrovalent bond. Okay. In ionic bonding, as the very term indicates, ions are formed. Ions are formed by either gain or lose of electron. The elements, all the elements which are known, except noble gases, they either have the tendency to either gain or lose electron, of which metals have more tendency to lose electron than gaining, and non-metals have the tendency to gain electron than losing. Okay, so when there is an attractive force develops between a metal and a non-metal, that means electron givers and electron takers, that result in the formation of ionic bond. Okay, that means first of all an atom should be converted into its ions by either losing or gaining electrons. By losing electrons, they become positively charged ions. By gaining electrons, they become negatively charged ions. And after this gain and lose, the one who gained and the one who lost will stay together. The force of attraction of opposite charges keep them together. That means I told you positive and negative ions are formed from the atom, from the neutral atom. Why an atom is called neutral? Because it contains equal number of proton and electron. And when an atom loses an electron or gains an electron, this balance between proton and electron are affected. Okay, so they either have extra neutron or extra proton. They are not equal in number. Proton and electron are not equal in number in ions. This the one who loses electron, as I have told you, will be called as positive ions because they have excess protons. The ones which have gained electron are getting extra electrons, means extra electrons carry extra negative charge, so they are getting negatively charged ions, and these positive and negative ions stay together, causing the ionic bond. Okay, and this the force of attraction that keep them together is called the ionic bond. Okay, and by doing so, by formation of an ionic bond, both the cation and anion, both the positive ion and the negative ion are getting stabilized. Stable electronic configuration they attain by losing and gaining electron. Let's see with one or two examples. So here we have the example of sodium and chlorine. Sodium with electronic configuration 281, that means atomic number of sodium is 11. Okay, so it has 11 proton and 11 electron in its atom. Its electron can be arranged, or electron arrangement, electronic configuration is 281. That means 2 electrons in the innermost shell, 8 electrons in the second shell, and 1 electron in the outermost shell. This is the electron arrangement for sodium. Okay, and sodium atom. And if you look at chlorine atom, 17 is its atomic number. That means 17 is its proton and electron number. So electronic configuration is 287 in chlorine atom. Okay, so they are both just short of octet. That means one has one extra than the octet. That means when this one is lost, sodium can attain its stability, and when one is gained, chlorine can also get stability. Okay, one electron. Okay, when sodium loses one electron, it gets stabilized. When chlorine gets one electron, it also gets stabilized. So these atoms, sodium atom and chlorine atom, are highly reactive. They are very close to this octet state, that is stable state of electronic configuration, and they are very much in need of that. Okay, so they can easily get it either by losing or by gaining. Now sodium atom, as I told you, have the tendency to lose the electron. It can easily complete its octet by losing this one and only electron which is present there in the outermost shell. Okay, and this one electron, when taken by chlorine, it can also stabilize itself. So the one which is given by sodium, if taken by chlorine, both gets stabilized. But what happens to them? They are no more called atoms. Okay, instead they are called ions. After losing electron, sodium atom becomes Na plus ion. After gaining one electron, chlorine atom becomes Cl minus, chloride ion. Okay, and they have charge now, Na plus and Cl minus. Okay, this positive and negative charge attract each other. Okay, and this attraction is what called ionic bonding. Okay, a bond between two ions, positive ion and negative ion. Okay, this force is called the ionic bonding, and there are many examples, other examples given in your book with magnesium oxide or calcium oxide is given there. Okay, like that you look at the examples which are given there, and remember, this is the way to represent in a diagrammatic way ionic bonding. Ionic bonding is represented in this way diagrammatically. You may be asked to draw the diagrammatic representation of ionic bonding giving the name of a particular compound. Let it be calcium chloride, let it be magnesium oxide, or let it be sodium chloride, or anything. Okay, if you are asked to draw a diagram or diagrammatically represent, you may have to do it this way. Remember not to forget the charges, and remember to enclose them together in a box. It shows the togetherness after becoming positive and negative ions. They are staying together. That staying together is shown by the enclosed bracket. Okay, so this diagrammatic representation is very much important. Now, what are the features of these ionic compounds? Now we have studied now ionic bond. There are other examples given there in the book. Once you refer that, and if you have any queries regarding that, either through your class teacher, you let me know, then I will clear you in one of my videos. That can be done. Okay, anyway, now let's see ionic compounds. Ionic compounds, as they are made because of the ionic bonding, because of the attraction between oppositely charged ions, they are stable and they normally remain as solids at room temperature, or it is difficult to separate this Na plus Cl minus or Mg2 plus and O2 minus ions that easily. So they normally have high melting point, high boiling point, etc. Okay, this is all because of the high stability, and if anyone wants to separate these positive and negatively charged ions, they have to exert a lot of heat for that, a lot of energy for that. Okay, that is the reason why they normally exist in solid state with high melting and boiling point. I want to tell you one more thing about the ionic bonding, and then we will proceed to the next type of bonding, that is a covalent bonding. Okay, here if you have noticed, you can find the difference of sodium atom and sodium ion. Sodium atom has 3 shells. 281 is the electronic configuration, and in sodium ion it's only 2 shells. 2 electron shells are there. 28 is the electronic configuration. Okay, so sodium, by losing that 1 electron, has lost 1 shell also. Okay, so obviously sodium ion is smaller than sodium atom. Okay, this can be generalized like, for every cation, every positive ion will be smaller than its parent atom. Here the parent atom is sodium atom, and this is the ion, positive ion. So positive ions are always smaller than the parent atom, and negative ions are little bit bigger than the parent atom, because an extra electron, even though the number of shell is same, okay, but 1 extra electron is coming in. Okay, from sodium 1 electron goes here to make it 7 and 7 plus 1, that is 8. This 1 extra electrons coming cause some disturbance in the atom. Okay, reduces the nuclear force and the inter-electronic repulsion. That means 1 extra electron when comes, it causes repulsion between the other remaining electrons. Already 7 are there, 1 more is coming, means repulsive force is there between the electron. This causes a little bit of expansion of the shell, and that causes a slight increase in the size of the negative ion. So chlorine atom will be smaller than chloride ion, but sodium ion will be smaller than sodium atom. Okay, for a positive ion, the parent atom will be bigger. For a negative ion, the ion will be bigger. Okay, more clearly. Okay, that's all regarding the ionic bonding. Now let's start discussing about the covalent bonding. So now you know that ionic bonding occurs between a metallic element and a non-metallic element. That means there should be an electron donor and an electron acceptor. Okay, and the conversion of these electron donors to positive ion and electron acceptors to negative ion, and the attraction between them. And here in covalent bonding, that normally occurs between non-metallic atoms. Okay, occurs between non-metallic atoms. That means neither give nor take of electron takes place, but there is a sharing between the bonding atoms. Okay, sharing of electrons take place between the bonding atoms. That means shifting of electron from one atom to the other don't take place. Instead, they will contribute equally and share mutually. Okay, equal sharing and mutual contribution takes place during covalent bonding. For example, if you take hydrogen atom, a single atom of hydrogen is not stable. So when another hydrogen atom comes with the same problem, that means instability because of one and only electron, what they both will together do, they will contribute their electrons for the common purpose. Okay, they will give, each of them gives their electron, and both these electrons are shared by both the atoms. Okay, so equally they are contributing one each electron, and they are sharing both these electrons, and as they are sharing electrons, they stay together, they are in bonding, and that type of bonding is called covalent bonding. covalent, covalent bonding takes place in elements, in atom, between the atoms of elements, and in the compounds like water, carbon dioxide, methane, etc. Okay, so now in today's class we are going to see only the covalent bonding in the elemental form. We will take the example of hydrogen, oxygen, etc., and you will find how covalent bonds develop. If you look at the diagram, you can easily understand that how covalent bonding happens between hydrogen atoms. If you look at, hydrogen has atomic number 1. Every hydrogen atom has 1 electron. Its electronic configuration in the one and only shell, 1 electron is there. So these two hydrogen atoms, when they are in contact, what they will do is they will contribute their electron, one each electron. Okay, they come in common and they will be available for both the hydrogen atom, or rather we can say both these electrons which had come from each of the hydrogen atom, one each from every hydrogen atom, will be kept somewhere in the mid of both the combining atoms, and that is available for both the hydrogen atom, and that result in the formation of a molecule of hydrogen, that is H2. We say that naturally hydrogen atom doesn't occur as a single atom. Okay, instead it is in the form of a diatomic molecule. The reason is this: when it is single, it is not stable, so it finds another hydrogen atom and develop a bond, sort of sharing of electron between them, that causes the formation of diatomic molecule of hydrogen. Okay, and one each electron is contributed, so there is, it can be represented as H, single line H for hydrogen. That means H, single bond H. Hydrogen molecule can be represented like that. And now look at oxygen, where the atomic number is 8, electronic configuration is 2, 6, 2 in the innermost shell and 6 in the outermost shell. Okay, when two oxygen atoms, they are not stable because they do not have the stability of octet. Okay, so they want to be stabilized, they want to have the octet complete. And for that purpose, when two oxygen atoms come, what they will do is they will share 2 each. Every oxygen atom will share, will donate, will give 2 electrons for the common purpose. Okay, sharing only happening, not complete transfer of electron. 2 electrons will come out, will be given for the common purpose from this oxygen atom, and the other one, oxygen atom also will do the same thing. Okay, so 2 to 4 electrons. You can see here 4 electrons are somewhere kept in the mid of both the oxygen atoms, and these 4 electrons are available for this oxygen atom and this oxygen atom as well. So including these 4 plus 4, remaining 4, its octet is complete. Okay, this 4 plus 4, the other one's octet is also complete, and they got the stability by this sharing. Okay, and this bonding can be represented like this with double lines between the oxygen atom, indicative of a double bond. Double bond means 2 pairs of electrons, total 4 electrons. One pair is donated by one oxygen atom, other pair is donated by the other for the common purpose. Okay, and they are sharing. Each of them has a hold on these electrons. Okay, these electrons are neither towards one oxygen atom nor towards the other. Okay, they are at equidistant between both the atoms, so, and available equally for both the atoms. It accounts for stability, and they are stable after forming the diatomic molecule, after forming two covalent bonds, O double bond O, between oxygen atoms. They are stable and because of this stability they stay together, because of this bonding they stay together. And this is the second example for covalent bonding in the elemental form. Now in the next class we will study about the covalent bond formation in compound form. You may be asked to draw the diagram like this in order to represent covalent bonding. So you must remember what is the difference between covalent bond and ionic bond. In ionic bond, the atoms are, the outermost shells are not overlapped, and here it is overlapped. See, there is a common area where the shared electrons are kept, are there in the covalent bonding, and this common shared area is not there in ionic bonding because complete electron shifting, complete electron transfer takes place. Okay, this is all about today's class, and in the next video we will further discuss about the covalent bonding in compounds. And until then, stay safe, take care, thank you.